it says, turn left, turn right. No.
For 42 years, Gladys was employed by the U.S. Navy. As a mathematician, she would help lay the groundwork for many of the government's orbital satellite projects. That includes what became the Global Positioning System, or what we call GPS.
We didn't do all the GPS stuff that's for the car and all, we didn't actually do that. But what we did was got the accuracy of where things were located all around the world and stuff, and it's a database.
Born in 1930, Gladys grew up on her family's farm just south of Richmond, Virginia, where she learned the value of hard work. And that would pay off for Gladys, who wanted more than what life on a country farm could offer.
You could get a scholarship if you were the first or second in your high school graduating class. So right off, I was Johnny on the spot, doing all my work all the time.
She finished at the top of her high school class, earning her a full scholarship to what was then called Virginia State College, a historically Black school in Petersburg, Virginia.
The teachers were encouraging me to major in math because they thought that I would be good.
Again, Gladys finished at the top of her class and went on to complete her master's. In 1956, she accepted a job at the Naval Support Facility in Dahlgren, Virginia. The space race was just taking off, and computers were the wave of the future.
It was really an excitement, They promised us that they would teach us, how to communicate with this computer and all this stuff, So, knowing me, I was ready to, to work hard with it.
And work hard she did. With the success of the space program, NASA was beginning to place satellites into orbit. Gladys was tasked to help write and program code needed to process the enormous amount of data coming in.
You have a long equation in there, certain coefficients that go along with each term. You have to generate them, get them accurate and all. Our program encoded all those equations, and we checked them out by hand cases and all. And they were passed on to the next level.
The work was long and tedious. Every equation checked and rechecked for accuracy.
You didn't want to cause anybody else any holdups or any trouble about something that you had done that prevented them from making progress. So you want to have to make sure that they could depend on anything that you sent.
It was this tenacity and dedication that drew the attention of fellow mathematician Ira West. The two dated for 18 months before getting married in 1957.
She wasn't an easy catch, Let me tell you, I had to work hard for that.
I always think of Ira. I always tell me, I said, he played more than I did.
Meanwhile, the civil rights movement was sweeping the country. Gladys and Ira wanted to show their support, but government employees weren't allowed to participate in public demonstrations. So the couple decided the best way to help was to change perceptions and work even harder.
We just were pushing. We couldn't participate directly, but indirectly in the situation.
That was another reason why I felt that I always had to be my best. And I always had to be a role model.
In the years that followed, they both continued their work for the Navy on numerous projects. In 1978, Gladys received a commendation for her work and was promoted to project manager of the CSAT radar altimetry project, the first satellite that could collect data across the ocean's surface.
It was always interesting working with people and doing something that was important and that's going to be used by the government and all. You got to make sure you're doing everything right because you're part of this big thing that's happening.
As she always had, Gladys stayed true to herself, striving to be defined by her competence and not by the color of her skin.
I think I was most happy when I got to the point that I could be independent and I could troubleshoot big programs and help to the analysts who had helped to generate the program. When I could talk to them, it's sort of like be a part and understand. I think that was the best feeling I had.
Even after retiring in 1998, Gladys stayed busy, completing her PhD in philosophy and writing her memoirs. For all of her accomplishments, commendations, and recognition she has received over her career, Gladys understands there is only one who she can credit for the direction her life has taken.
So this woman came from nothing, not nothing, but certainly not an academic environment. And through hard work, was able to produce something that's meaningful. How many of you use a GPS on a daily basis, right? Your parents certainly do with Waze and whatever else we do, right? And today, what we're going to be working with is coordinate geometry, which is a way of identifying with precision what a shape might be classified as. What shape is this? Quadrilateral. Excellent answer. Can we give any more precise answer? Is it a square? Could be. Is it a rectangle? Is it a parallelogram? Is it a rhombus? What information would we have to be able to make that conclusion? Okay. If you flip this document on your desk in front of you, you'll see some coordinates. Now what shape is it? Ask and ye shall receive. You got 4 coordinates here. What shape is it? Quadrilateral. Okay, good. It might be a rhombus, but how can you know with certainty?
Well, no, because this is like 9 and 8, and then like 2 and 3. I don't know. It's the spacing of the points.
Spacing of the points. That's really important, isn't it? So over here on the right-hand side of this picture, I'd like you to draw, remember the Euler diagram we did? We talked about how within all the quadrilaterals, the biggest group is the parallelograms. And then within that, there were 2 other groups. We could have a rectangle overlapping with a rhombus. And then this is the square. And then outside here, we haven't really gotten to this yet, but the trapezoid and the isosceles trapezoid. And then out here, this little high flying kite thing. So what we want to do is we want to figure out with these 4 coordinates where it exists. It could be out here. It could be a quadrilateral that has no sets of parallel sides. Could we take these coordinates and find out if they're parallel? Do you guys know how to determine if 2 lines are parallel? The slope. If you look on the board near the agenda, in blue, it shows the slope formula. We could find the slope formula between 2 points and see if they're parallel. But that only gets us so far. If in fact it is a parallelogram, we would know that opposite sides are congruent. And we'd also know that the diagonals are not congruent if its best classification is a parallelogram. If the opposite sides are congruent and at the same time the diagonals are congruent, it's a parallelogram, but it's a more special one. It's now a rectangle. If the opposite sides are congruent, the diagonals are not congruent, but we also see that all 4 sides are the same. It's a rhombus. If the opposite sides are congruent, diagonals are congruent, and all 4 sides the same, it's a square. So to be efficient, we only need one formula. We need the distance formula here. Do you remember the distance formula?
y1 minus negative y2 plus negative plus
The negatives aren't part of it.
not negative.
Nope. But I like what you're doing. You're saying, I'm going to take the difference between the x's and the y's.
I know what it is. It's the square root of x minus y, or like the x minus the x and the y minus the y on both coordinates.
Right. Take the difference of the x's, square them, add to the difference of the y's squared, and then square root the whole sum. So put this on your notes, please. You'll need this. You're going to use this a lot. Okay, now if we want to see if this particular shape, quadrilateral ABCD, is a parallelogram, we need all four sides. So let's do that. The first side would go from A to B. So I'm going to write AB is equal to, and it's going to feel tedious, but after doing this a few times, you will have a level of proficiency earned through hard work that will make this easy. So we're going to take the difference of the x's. B's x is 8, A's x is 9. So 8 minus 9, negative 2 minus negative 4. And we'll say, okay, so that simplifies to say negative 1 squared plus positive 2 squared. I'm going to do the square part before I do the plus part. That's really important. What do you need? So 1 plus 4 is the square root of 5. And we don't really need to take it any further. What we're trying to do is compare one leg to another leg. So as long as it's in a simplified form, that helps us. Let's take the next leg around the triangle, excuse me, the quadrilateral, B to C, and find the length of that segment. So again, it's the sum of two parenthetic squares, 2 minus 8 in the first one. What goes in the second one? Negative 5 minus negative 2. So that's negative 6 quantity squared plus negative 3 quantity squared. And again, this is where people tend to make mistakes. Make sure you square it before you do the addition. So this comes out to square root of 45. Is that the same as the square root of 5? No, it's not. So that's important. Yes, go ahead.
By addition, do you mean the addition within the parentheses or the addition where it's like add? Okay.
Right here. I'm concerned that people would see this negative 3 squared and say that'd be 36 minus 9. We don't want that. We want 36 plus 9. Because the negative 3 squared makes a positive 9. Okay. CD. So 3 minus 2 squared plus negative 7 minus negative 5 squared. Then we get a square root of 5 again. It's a good sign. Do we know what shape it is now? Can we limit choices? All we know is side lengths though, right? We only know 2 of them, so nothing yet. What's the 4th side we want to compare? Good, DA. Kind of wraps around. That's going to be 3 minus 9 squared plus -7 minus -4 squared, which is -6 squared plus -3 squared. Again, 36 plus 9 is root 45. So underneath this, let's write conclusions. What conclusions can we make here? Yeah, Josh.
It's not a rhombus or a square.
I don't, oh, okay, right, because adjacent sides are not congruent, right? I'm going to make that our second conclusion. Our first conclusion is that opposite sides are congruent. Which means it is what kind of shape? Good, parallelogram. Opposite sides are congruent, making a parallelogram, which means in my little picture here, we know it's not out here in this area, right? It's not a trapezoid, it's not a kite. It's somewhere inside the parallelogram world. Okay, and Josh just gave us another fact. He said, I noticed that the adjacent sides are not congruent, which means it's not a rhombus. I did this backwards because adjacent side's not congruent. So that means we can cross out the rhombus, and notice that that means not only crossing out the rhombus, but it also means crossing out the square, because the square is a rhombus. So what do we have left? It's either a rectangle or just a parallelogram. What's the distinction between those two? What feature would we look for to see if it's a rectangle versus a parallelogram? The diagonals. So if the triangle or this quadrilateral is ABCD, what's a diagonal? A and C, right? Skipping them. And B and D. So let's do that. AC, the distance, is 2 minus 9 squared plus -5 minus -4 squared. So -7 squared plus -1 squared. 49 plus 1 is root 50. Okay, let's do BD. These are the diagonals, right? They're going across.
How do we know which one's in the black?
Yeah, right. So when we do adjacent vertices like A and B and B and C and C and D and D and A, the ones right next to each other are side lengths.
How do we know those ones are right next to each other? Does this go in order?
Yes. Yep. When you name it A, B, C, D, that means it goes in order in that direction. Okay. So then BD.
After D squared. Oh, that's not D, that's
-1 quantity squared. Yeah.
Okay, I thought that was
It looks like a D. Any predictions at this point before we actually do the calculations? Who thinks it's a rectangle? Raise your hand. Okay, let's see. So then we're going to say 3 minus 8 is -5 squared plus -7 plus 2 is -5 again squared. So 25 plus 25 is square root of 50. Look at that. So this is our third conclusion. Diagonals are congruent, which means rectangle. In fact, this is where our shape is. Five. It's a bit tedious, but I believe I can do this process. I understand it. 3. I'm a little confused about a couple of steps. These are good, clear notes. Hopefully I'll be able to gain how to do it from these. 1, I don't understand at all what you're doing. I can just look at a picture and graph it. Okay, hands down. Do you think Gladys West did this level of tedium? To some degree, but don't you think she was actually smart and used computers too? Like, isn't this process something we could reproduce in computers?
Actually, like, it would need to be, I mean, I don't know if we really have computers, at least like at our disposal, say in this class, but like.
Well, anyone recognize this thing? What is this? Google Sheets. What's your familiarity with Google Sheets? 5, it is my jam. 3, I have some familiarity, but I have not used it much. 1, it's pretty. Okay, so I've gotten at least one career job by knowing this spreadsheet program. Like, I went into software as a financial analyst because I knew how to use this program. I think this is something everybody should learn. And I'm going to take a moment now to show you how it might be used. For some of you, this might be, okay, this is super boring because I know this so well. Others, it's going to feel like I'm waving a magic wand over here. But please listen and watch and see if you can understand what's going on with it. What we're doing is we're taking coordinates. For example, we just did this one and we're going to analyze it. I'm going to take point A and point B. In other words, I'm looking for the length of segment. No, let's hold on, let's do it differently. Let's make point A there, point B, point C, and point D. And then this is going to be my X value. This is going to be my Y value. So what was the X value of A here? 9. And my Y value? -4. What was my X value of B? 8. My Y value? X value of C? Y value? And D? Okay. Now, the whole point of Excel, or in this case, Google Sheets, which is basically the same thing, is that you get to create formulas based on locations in the sheet. So for instance, if I want to find the length of AB, what I can do is I can say, let me just create another. I'm going to say length. And then I'll go to the next cell and say, I'm taking this letter. And then next to it, I'm taking the next letter, B. And my formula is then going to be equals parentheses. I'm going to put a double parentheses in there because I know what's coming. I'm going to take the X value of B minus the X value of A, close parentheses. And I'm going to put a little caret on that to square it. And then I'm going to add another parentheses. And what goes next? Y2 minus Y1, close parentheses, square that, close this whole thing. And I could do it two ways. One, I could do the 1/2 exponent because I know what that is. But what I could also do is get right in here. Is that after the equal sign?
No.
Now is it after the equal sign? Okay. And I could type a function. They've got these cool functions. In this case, it's square root. In other words, that tells me the length of AB. Okay, that was kind of a lot of work, right? But here's the whole point. What if I just copy this down? Now, if I copy it again, will it work again for my fourth side? No, because it's going to say like, take this coordinate and this coordinate, and I don't have A down here. But could I? I'm going to say from here, go up to there and pull that value in. And now I get dA. Our opposite side's congruent. Now, here's the whole beauty of this, right? Okay, that was a little faster. This is problem example. I'm going to copy this, paste it here. Please flip your page over to page 2. Okay, what are my letters here? S, T, U, V. It automatically knows that that first one's going to be S again. What's my S coordinate? Okay, what's my T coordinate? Okay, my U. And I don't even have to do anything. It automatically tells me that these are the lengths of all these segments. ST is this long, TU is this long. Saves a little time, doesn't it? Now, we're not done though, right? Because here we were able to say opposite sides congruent, parallelogram. We're able to say adjacent sides not congruent, not rhombus. Oh, that's a little tight there. So I'm going to come over here and just right click insert and insert another row so I can see that better. And it's not changing any of this stuff because I'm inserting a whole row. But what we haven't done is the diagonals. It is just a new row, isn't it? So we just have to go length. And this time, let's take 2 of these things and make them more narrow just so they fit better. I want to do A and C, right? And then I want to create another formula again. Oh, well, I did the formula here. So what if I just copy this whole formula and then I come over here and paste it, but I'm going to have to make some edits because this was doing like row 1 and row 2. But if I come in here, it shows me with colors which things I'm doing, and I could actually, that worked? No, that didn't work. Let's do that again. And you know how Gladys West had to work hard and do some diligence? We might have to play with this a little bit. And I can't see this enough to be able to do this. Okay, inside this thing, we're at D5 minus D4. What we want is D6 minus D4. And E6 minus E4, and that's now AC. And if we're unsure of it, what we can do is, again, click on it and see which colors it shows me. Okay. And then, of course, I can just say I want to copy this down. And it's BD. And we want to do the same thing. And I have to make sure when I copy it, I line it up correctly, right? It's right along with A and B. And there. So what are we going to say here? What are our conclusions? Good. Opposite sides congruent. 1 second, Donovan. Therefore, parallelogram. Adjacent sides congruent. Therefore, rhombus. Diagonals congruent. Therefore, square. Cool. If you would like to, instead of doing this on paper, if you'd like to crank this out on a Google Sheet and send the link in to show me that you did it that way, I'm 100% okay with that. I think this is a more valuable skill. You've only got about 10 minutes, but the rest of the period is yours to do these problems. Make sure you write the conclusions here as well. So say CUV is a square. Yes.
What happens, like, are those go like this?